Almost 8 million people clicked on a 3.5-hour lecture about ChatGPT. Almost nobody made it to the end. The man giving it is Andrej Karpathy, a founding member of OpenAI, the former head of AI at Tesla, and the person who coined the term vibe coding. And buried in those 3.5 hours is his strangest claim. When you type into ChatGPT, you are not talking to a genius. And you are not talking to the internet. You are talking to what he calls a simulation of a data labeler. In the next few minutes, you'll know exactly what that means, the 3 steps that build a ChatGPT, and 1 practical trick from each step that makes the AI work better for you. Step 1. Take the internet and compress it. Before a model can chat, it reads billions of pages, playing one single game over and over, guess the next word. Every time it guesses wrong, its internal settings, the weights, get nudged. Do that trillions of times, and something remarkable happens. The knowledge of the internet gets squeezed into those weights. Karpathy describes the result as a lossy compression of the internet, and lossy is the key word. Like a badly compressed photo, the overall picture is there, but the fine detail is not. The model remembers the gist of almost everything, and the exact source of almost nothing. And here's a detail most people never learn. The model doesn't even see words. Before anything reaches it, text is chopped into tokens, chunks that are often pieces of words, each one just a number. That's why early models famously insisted there were 2 R's in strawberry. They were never looking at letters in the first place, they saw a few token IDs. Today's models handle spelling far better, but the lesson still stands. The machine reads the world in tokens. Keep that picture, it explains more weird AI behavior than almost anything else. Step 2 is where the personality comes from, and it's the step that gives this video its strangest sentence. A freshly pre-trained model doesn't answer questions, it just continues text. So companies hire real people, data labelers, to write tens of thousands of examples of ideal conversations. Here's a question, here's the perfect helpful answer, following a detailed style guide. The model is then trained to imitate them. So, in Karpathy's words, what you're really talking to is a simulation of a data labeler, not a mind, not a database. A statistical imitation of what a careful, helpful human writer would type, one that answers in seconds what took those writers hours of research and whose manners, tone, and habits all came from them. This recipe also explains AI's most famous flaw. When the model doesn't know something, it often doesn't stop. It produces something fluent and confident and completely made up. Why? Because in training, confident, complete answers were the pattern to imitate, and honest, I don't know barely appeared. The fix that labs applied is two-sided. Deliberately train the model to recognize the edge of its knowledge and say, I'm not sure, and give it tools, like search, so it can look things up instead of recalling them from that lossy compression. Which gives you Karpathy's first practical rule. The model's built-in knowledge is what he calls a vague recollection, like something it read a month ago. What you paste into the chat is its working memory. So give it the facts, or let it fetch them, don't make it remember. Here's the second practical rule. In 5 words from the lecture, models need tokens to think. Every single token the model produces costs it a fixed small amount of computation. There is no pausing to ponder. The thinking is the writing. So, if you demand the final answer in 1 word, you're forcing the model to solve the whole problem in 1 computational step, and it will often just guess. Let it work step by step, and the reasoning gets spread across many tokens, each one a little slice of compute. That's not superstition, it's the architecture. Step 3. Practice. Imitating humans only gets you so far, so the final stage lets the model teach itself. Give it thousands of problems where the answer can be checked, like math and code. Let it try many solutions. Keep and reinforce whatever reached the right answer. This is reinforcement learning, and it's how the reasoning models emerged. When one lab, DeepSeek, trained a model this way, its written chains of thought spontaneously grew longer. It discovered, on its own, that thinking longer paid off. And Karpathy's reference point for where this leads is move 37, the famous alien move an AI played against the world Go champion. Strategies no human taught it, found through practice. He says reasoning models are showing the first hints of that in open-ended thinking. So how should you actually use these things? Karpathy's honest label is jagged intelligence. The same system that solves graduate-level problems can still stumble on strangely simple ones. The sort of model that could win math competitions has tripped over comparing 9.11 and 9.9. The jaggedness is real, and nobody fully knows where the holes are, so use it ambitiously, but keep it on a leash. Check the things that matter, because it is brilliant and unreliable at the same time. And that's the recipe hiding inside those 3.5 hours. Compress the internet into weights. Teach it to imitate ideal answers, then let it practice on problems you can check. If this made something click, 2 things. The original lecture is linked below. Karpathy is worth your weekend. And when you want the full picture, our channel has a complete free course on how AI actually works, from a single predicted word all the way up to AI agents. Subscribe, and it's all yours.